The following is a special series of the Darden Ideas to Action podcast, focusing on the power of disruptive innovations.
Good Disruption, a lively discussion between UVA Darden School of Business professors Yael Grushka-Cocaine and Mike Lennox on cutting-edge technologies and practices that are challenging the status quo.
Hello, welcome to our next episode of Good Disruption. I'm here with my co-host Yael. Yael, what are we going to talk about today?
Oh, I am really excited to talk about a topic which I think is going to fundamentally change our lives and for the better. We're going to talk about personalized healthcare or personalized or precision medicine. There's a lot of different terms out there. Maybe we'll get some clarity here today. But basically, we're talking about the field of medicine and how it's becoming more and more tailored to individuals based on their profile, based on their genome, based on their DNA, and everything that we can find out to the point where it's really customized to us as individuals, which is hugely fascinating and exciting.
I am excited to learn about this topic. I am admittedly, if I'm not out of my depth every time we do one of these podcasts, I am really out of my depth on this one here. I've always felt like I was someone who leans towards technology, but admittedly healthcare has not been an area of focus of mine. I think it was the 1C I got in college was like my organic chemistry class.
Your biology, yes.
And so I've shied away here. But I am intrigued by this topic and what it could mean for human health outcomes. So can you help us out here and help define what exactly are we talking about here?
Yeah, we're talking about a field that basically breaks it down to the point where it can learn about you as an individual, break down your chromosomes and really get a history about you as an individual. You know how you go to the doctor and sometimes they ask you questions about your parents and your parents' parents and your family history. Well, instead of you having to memorize that, or instead of it being very broad definitions, they can really learn about the exact composition of Mike Lennox, who you are, what is in your DNA that makes you so unique, which of course we all know that you're special. But what that means in terms of how likely you are to maybe, I hope not, but maybe be more a target to certain diseases. It can help identify which medicines would work on you better and which treatments would help you specifically tackle certain illnesses or certain diseases that are in your future. And so it can really create more of an individualized plan, identifying in our community, in our society, which individuals are more prone to certain health issues and how we can really treat them better, be proactive as opposed to reactive.
And I imagine a lot of this is being driven by the ubiquity at this point of the ability to map your DNA, like things like 23andMe and the like. Is that
those
accurate?
all have emerged from the same wave. The addition, like everything that we've been talking about in this show, it's about the ability to collect huge amounts of data. It's about storing that data and running more sophisticated algorithms. And now with projects like the Human Genome Project, which collected a vast amount of information, a lot of money is being spent in this area to not only collect, share, and process the data, but also come up with sophisticated algorithms to do the prediction that is needed.
Yeah, and I appreciate that kind of big data aspect. With 23andMe, have you done 23andMe or one
I
of
have
these?
not.
I have, and it is fascinating to see, first, where my ancestors came from.
Did you learn anything you didn't know?
I was a little scared because I know I have Scottish roots. I came out like 75-80% Scottish, which, given it's been like 200 years since my relatives immigrated to the U.S., we've been very inbred. It sounds like, if we still have such strong Scottish heritage there. But obviously, it goes far beyond that. Things about the likelihood that I would go bald. Luckily, I've got a full head of hair, so that I have the good genes for hair. You got good hair, so you got good genes for hair. And then, of course, what we're talking about here is then the ability to then maybe forecast and predict the likelihood of certain cancers or diseases that you might have.
Correct. I mean, breast cancer has fundamentally changed the treatment for breast cancer and the ability to detect up front who carries a gene that is now connected very directly to the chance of getting cancer at a young age. That can create vastly different avenues of treatment and really eliminate that from even becoming a possibility. So you're changing the future by having the information up front. In general, if we're in a business school, we care about the money here. if you didn't realize, this is a huge field, right? So global personalized medicine or precision medicine, the market size is valued, or at least it was valued a couple of years ago, close to $500 billion. It's expected to continue to grow close to $800 billion by 2028. I mean, there's a lot of money being poured into this, and really a lot of investment both in the healthcare sector, among doctors, but also in the private sector all the time.
How does this relate to, so talk about big data, other sources of data that's being collected on you individually about your human health? I think about, like, I have a smartwatch, I track when I work out. So now suddenly, instead of going to the doctor once a year and he or she taking 20 seconds to measure my heart, suddenly they have vast amounts of data about vital signs for me over the course of the year. Does that contribute to what we've been talking about here in terms of the kind of the DNA personalized medicine?
Yeah, I mean, it's a different it's a different type of data, right? It's data related to your daily activities. It has to do with the diet, with the environment in which you live, with your lifestyle and your practices and things that you can control more directly. But the combination obviously is taking us to brand new territories where we can really identify, put together the information about your DNA, your genome, your background, everything that is biologically part of who you are from creation, all the way to your habits today. If you put those two things together, you can be proactive and very reactive in the moment when you see things happening.
So that suggests to me kind of the classic nature versus nurture debates here. And one could imagine, are we going to learn that your health outcomes are really driven by your DNA, or are they driven by your behavior? Probably the answer is a little bit of both. But I start to think about some of the implications of that. If we're now, again, being able to screen and predict the likelihood of certain diseases, and it becomes maybe a factor in your insurance premiums or a factor in even whether you get hired into certain jobs.
Yeah, you can imagine that the extent, this information, which is new to some of us, can be used and abused in various different ways. And that's going to open the door to some of our debate here today, I can see already. But, if I'm told that I have tendencies related to, let's say, weight, what does it do to my desire to be on a diet or not be on a diet, or exercise or not exercise? Maybe all of that effort is not as worthwhile if I know that there are certain genes that I'm carrying that are going to dictate my future.
That's interesting. So you think if someone says you have the heavyweight gene, your reaction is not to work out more. It's actually to go the opposite way and say, hey, this is my DNA.
It's not clear.
It's my destiny.
It's not clear. And so that's where I think a lot of the medical field is fascinated by what are the prescriptions that we give these individuals with these certain combinations. How can we help them identify their path forward, given what we know about them, that maybe a few generations ago we wouldn't have that information at our fingertips.
This is probably like a deeply personal question, but I'm going to ask it nonetheless, is if you could know about some of these likelihoods, and you being a data scientist, you understand uncertainty and probability and statistics here, but if you're told, wow, you've got an 80% chance of getting breast cancer or a 10% chance of some rare disease, is that information you really want at the end of the day?
It's a great question. And I think that I've talked to people around me who have received that kind of information. And I think that it's personal, as you mentioned, and different individuals have different reactions. I think as a society, again, we're learning how to react to that information, and we're cultivating some language around it. It's and TV shows are showcasing subjects who are going through processes like that, and that's helping. But I think by and large, as medicine evolves, there are huge opportunities, because we can, if we see a certain chance of an event happening, the questions are, can we prevent them? What is under our control? What can we do to correct course? What can we do to ease our time and increase our life expectancy or improve the quality of our living under certain paths and certain conditions? And so then you have a whole new world of investments to cater to those opportunities and to prepare for them. And as we know, when we can control, destiny to some degree, see it coming, when we can prepare, we're better off for it.
It's interesting. I think as a parent, what we, our kids are relatively close in age. What we had to deal with in terms of some of the testing that could be done in the womb that gave you forecasts for conditions that your children might have. And in some ways, I fear for my kids that when they're having children, my kids are teenagers, that they're going to have such a vast, more array of predictions and probabilities here. And again, what do you do with this information?
I mean, at the end of the day, we've talked a lot about the trade-off. Improved predictability doesn't take away the decision-making capability. It empowers us to make decisions, hopefully better. More decisions are at our fingertips. So us as humans, our role is still very critical in all of this. The doctors, the physicians that are shepherding the patients through, and the subjects themselves have to make a lot of choices, and they just have more information to make it. So in theory, more information is always good. How do we treat it and how do we learn to make those decisions is something that we need to develop, a capability that we need to develop. And you're right. I mean, when I was pregnant, some of the genetic testing that gets done, I grew up in Israel, and a lot of the field there is very sophisticated in terms of exploring specific genetics that have to do with the people who are in Israel that are important to test up front because it helps people make better decisions.
Interesting.
Yeah,
Fascinating.
Yeah. You talked about the insurance and being rejected based on certain genetic profile. I mean, how do we think about that? How far can that go? I mean, there's a lot of...
Yeah, and I think, as we often do, like to think about some of the business implications and the way that might impact consumers in this case, or patients, if you will. I also think about some of the challenges around who gets things developed for them and who does not, right? So this has been an issue with drug discovery for decades here, is that obviously the most lucrative way to develop a drug is one that has a large number of people who are inflicted with whatever that ailment might be, so there's a large market for it. As a result, we get these kind of orphan categories that don't receive much attention. As we move towards more personalized medicine and that ability to really target certain drugs and treatments to specific DNA clusters, do we run the risk again of inequity,
Right.
where some people are going to get the attention and some people aren't? Is that going to be driven by wealth? The wealthy are able to get the customized drugs necessary for them, where others are not. These are in the back of my mind as well.
Yeah, it feels like there might be a potential to disrupt the entire, ecosystem related to the pharmaceuticals, the drug development process, the physicians who treat the patients in the hospitals and the clinics, and ultimately in the U.S. that also translates to the insurance market. But in other countries, that's a different infrastructure there that is all bound to be disrupted by some of these forces that are around us. I mean, it's interesting as we think about the last 2 years. Do you think the conversation around personalized medicine or precision medicine has changed due to the COVID pandemic? This has been a recurring question in our podcast as well, the impact of the pandemic on some of these disruptions.
I would imagine so, right? I mean, I think it's at the very least made people heightened in their awareness of the impacts of infectious disease, but those differential impacts. Right now, as we're sitting here, COVID is kind of raging again. Thankfully, the impacts in terms of hospitalizations and deaths has not been too bad. But it's fascinating in just, again, casual conversation with friends and family, how differently we are all reacting to COVID. Some of us have much more serious reactions than others. Some are, for example, losing their taste, which has been a issue with COVID from the very beginning. I would imagine there are genetic explanations for these differential reactions to COVID. And so I think people have a heightened awareness right now about this kind of notion that your genes are destiny and it can impact you. So yeah, I would imagine that would make people more receptive to this right now.
And maybe a fun thing that I don't know if you read, but our great Becky, when she did her research, highlighted a really cool or out there idea that kind of, again, brings together some of our podcasts over time. There's a company called Genetica, a genomic company that is basically working in the Asia-Pacific region. And recently they partnered with Oasis Lab. And what they do is it's a Web3 data management company. And really what they do is they tokenize your genome. They really take it and create basically like a genetic, I would say, NFT, like a tokenized version of your genome for you to own, and so you can have more control about your personal kind of profile in this virtual world that we've been talking about. Isn't that exciting?
That's exciting. Just please don't say now we're going to make this a cryptocurrency. Trade.
Maybe we're going there.
No.
There.
But I get the idea. Yeah, that this gets to a broader set of questions of kind of health records and digitization more broadly. Who owns your health data? But it's a really interesting observation that those conversations, which you might argue is separate than what we're discussing today, come to bear very quickly when you have very personalized information like your DNA, like your genome, and you need to share this with others, but it's very private information as well.
We want you to own it, yeah. And I mean, there's been so many struggles for so many generations around electronic records and how can we get these, this information to be collected and stored in a more responsible, organized, and efficient manner. And maybe we just step over that whole debate and instead of trying to get everybody to a place where they have these electronic records, we just go into the Web3 and tokenize it.
And I know these questions have been raised with companies like 23andMe because they're sitting on this literally treasure trove of data on individuals, and hopefully they'll be good stewards of that. But you could imagine it being used for nefarious purposes.
Well, I think it's about time that we brought in some expertise to this conversation.
Absolutely.
How do you feel about that? Well, we have an amazing guest here, Eli Williams, a PhD, an associate professor of pathology, director of the genomics and the cytogenomics department at UVA. Eli, welcome to our podcast.
Thanks for having me.
Eli, we should probably begin with, so what have we messed up so far? I'm sure I've used language incorrectly multiple times here and have misunderstood certain concepts. Have we messed anything up that needs to be corrected so far?
No, I don't think so. I think you've hit the highlights pretty well. It is the naming of this field has been a little confusing. I think you hit on that at the top. It's personalized medicine. It's been called precision medicine. And if you want to even drill a little bit deeper, it's been called personalized genomics. To me, really, all those things are very similar. And as you said, just kind of using, a person's unique molecular biomarkers to really customize their medical treatment and get improved outcomes. That's ultimately the goal of this field.
And so the precision, where does the word precision come from? What does that allude to in this context? I know I just want to maybe help people get some insight.
Yeah, so the precision medicine aspect really, I think, comes mostly from cancer treatment, where a person might have a very specific DNA change that's characteristic of their very specific cancer. And what drug companies are really trying to do is target therapies specific for those changes, those precise changes for that cancer to get better outcomes. So that's where that term precision medicine comes from.
On that last point, we mentioned before, I mentioned this issue potentially around the economics of drug discovery. How do those pharmaceutical companies approach such customized development? Again, I think about the idea of large molecule, like you want to have a large volume of people that you sell this to. How do the economics work here for that kind of customized drug discovery?
Yeah, so I think really one of the challenges anyway for drug discovery is finding targets that they can actually drug, right? So in cancer, we're looking at, tens or even hundreds of DNA changes or mutations for that are specific for that cancer. And really the challenge is finding which one of those mutations is really just driving the cancer and also something that can be drugged. And so that's really where a lot of the time and effort is spent. So whereas you would think you would want to market it as broadly as possible, really they're just looking for something that's making a difference, something that's leading to improved outcomes, to cancer remission and those kinds of things.
That's super helpful. We've asked ourselves this, but we're not as knowledgeable. I'm curious to your take on why now? Like, why are we seeing an interest in this field? Why is the investment, it's all happening? There seems to be a lot of, excitement around investments and private companies emerging and VCs willing to go there. Why now? What is going on in the world around us? What is available to us that didn't exist, 20 years ago?
So there's a couple things. I think it's kind of a confluence of multiple different factors. I mean, definitely the technology is a big thing that's driving this right now. The Human Genome Project in about 2000 kind of revolutionized some of the technology that we use to look at DNA. But at that time, it was really expensive. They spent almost $3 billion on that initial human genome. And over the last couple of decades, the technology has gotten better and better. And now we're down in some cases, as low as almost only $1,000 per genome. So certainly it's much more accessible and cheap to do. I think another thing that has really led to this is we're starting to understand the genome a lot better. Prior to the Human Genome Project, we really only had deep information about maybe a couple of the genes, a couple of critical genes in our genome. But as we've sequenced more and more people in different populations and in different disease states, we've really started to understand a lot more about the genome and exactly what it means and exactly the impact that different mutations might have on a particular person's health or other outcomes like that. And so by having the technology be a lot cheaper and the knowledge be a lot higher, people are starting to come up with novel ways to leverage their genomic data to improve their health outcomes.
Is it that we have sufficient data, we just need to do the analysis, or do we need to continue to expand the pool? We need more people to go get their genome mapped and the like to continue to make advances?
Yeah, I think we need to be a couple things. I think the genome needs to be looked at in a lot of different ways. We think we have 3 billion base pairs in our genome. Only about 1.5% to 2% of that actually encodes for genes. We need to figure out a lot of what the rest of that material even does. And the other thing that is very challenging sometimes with genetics is that two people can have the same genetic change, but they can have a different clinical presentation of disease. And is that a result of their other genetic backgrounds, like other mutations or variations that they might have in their genome? Is it a result of the environment or something else that they've been exposed to over time? And those kind of real complex kind of data analyses are what we're still kind of waiting for. Really what we've tapped into are the mutations that have a really significant phenotypic effect on an individual, the high yield kind of genes. And really what we need to do is kind of figure out all these genes that are having really kind of small or medium-sized effects on a person's health. How do we add all those small changes together to have a really clear picture of their health and their outcomes?
This is fascinating. Tell us a little bit, from your perspective, Eli, what is the reaction among the doctors? Like people who go to medical school, are we teaching them anything differently? Is this introduced earlier on? Is this being embraced by the medical community? I can imagine that it really requires like a digital mindset, like a new mindset for the younger generation of doctors.
Yeah, so it's definitely changed healthcare, and it continues to change healthcare, and I think it will do that for the foreseeable future. I think genomics is starting to touch not just cancer, which is primarily where we think about genetics, certainly pediatrics and rare disease, but really in a lot of different situations, it's really starting to be used more commonly for a variety of different clinical purposes. And so, it still is a little bit in the wild, wild west phase. We're still really trying to figure out exactly what test should be ordered for which patient and at what time. That's really what we want to do is the right test for the right patient at the right time. But we just don't quite have a strong enough knowledge base to be able to do that efficiently in every situation. And so it is changing rapidly, and there's still a lot of questions. And certainly the medical education for our doctors is starting to change, but I think it's something that we need to accelerate a little bit faster, because inevitably the doctors that are coming into the workforce today, they are going to need to order genetic testing at some point in their career, and probably for some, it's going to be a regular part of their practice. And so really ramping up that education and the understanding is going to be important for making sure that genomics really has the positive impact that we think it will on population health.
I raised the kind of nature versus nurture, classic question here. I'd be curious, like, what are your thoughts on the behavioral side? How does that interface with the work you're doing in the genomic side?
Yeah, so they go hand in hand, but the nature nurture question is not answered for sure, and I don't think we're going to answer it for a while. It's challenging. For diseases like autism, we know they have a really strong genetic component, right? And we see it in siblings. Multiple affected siblings in the same families will have the same kind of behavioral phenotype, and we can do genetic testing and we can find genetic variants that are specific to those kids. But what we also see is that the parents will often have the same thing, and the parents don't seem to show the same phenotype. And so what do we make of that? Is that just something the gene is not being expressed, or it's being expressed differently in those kids? Or is it something in the environment that triggered that gene to act in a different way? And those are really questions that we don't have great answers to yet.
Yeah, that's fascinating. And I can imagine a whole slew of, interesting areas to dive into research. Do folks in the field care about the whole notion of fairness and accessibility? Is that something that you can allow yourself to focus on, or do you have to continue with the scientific discovery around the genomic, combination and not worry too much about the accessibility question?
No, I think accessibility is definitely something that we think about. I mean, genetic testing is expensive. As in the healthcare setting, it's an expensive test to order. That I'm talking thousands of dollars. Insurance is often spotty in terms of its coverage. It's often considered experimental, and in some places, we're fortunate here to be at UVA in an academic medical center where they embrace new technology. But in a lot of community practices and those kinds of things, they may not be thinking or may not be ordering these expensive tests for their patients. And so there's definitely an accessibility issue with genomics. And really what we want is everybody, with that needs genetic testing to be able to get genetic testing, but we know that's just not where we are currently.
Is it a matter of expense only, or is it also like expertise in these like regional hospitals and the like?
Yeah, I think both, Mike. I think that in some cases in unusual or rare presentations, they might not just be thinking about genetics. They might just be trying to figure out, what can I do for my patient here, not knowing, there might be a new genetic test that's just out that might give me a little bit more information, because these genetic tests, I mean, are coming on the market very rapidly, and the time it takes to develop a new genetic test is getting shorter and shorter. And so we're seeing really, I think, as was alluded to earlier, an influx or a huge increase in the number of genetic tests that could potentially be ordered. And so that expertise is really critical to make sure that, one, they know that there's a potential genetic test that might be useful in a certain clinical situation, how to order that genetic test, and really what to do with that genetic data when they get it back from the laboratory.
Yeah.
Is this something, another disruption in healthcare, telemedicine? Is that something that is helping with this potentially?
To some extent, I think it gets people in touch with experts that are able to help them. But if they're not being referred, effectively, then they're still not getting that care. So it certainly provides some additional accessibility, but ultimately they need to be talking to the right people and getting the right tests, which is something that personalized genomics in and of itself is not really addressing.
And, as we talk about issues of accessibility and fairness in terms of access, both in terms of the physicians that are located or in terms of the cost, there's a whole other slew of issues that come up when it comes to healthcare related to discrimination and profiling. Again, you mentioned, I think, in previous conversations that we've had, that there are protection acts, tell us maybe a little bit about GINA and how that comes into play.
Yeah, so we in the U.S. anyway, we have some protection that our genetic information cannot be used against. So it's the GINA is the Genetic Information Non-Disclosure Act, and so what that protects us from is from if the insurance company finds out that you have a particular genetic variant that predisposes you for some adult onset disease, they cannot exclude you or change your premiums based on that information. Because you can imagine if that protection wasn't there, and insurance might say, this person's going to get Huntington's disease when they're older. That's going to be really expensive for us. So we're going to charge them, thousands of dollars premium to protect ourselves from that particular situation. So those kinds of really broad protections are there. But, in that same example, it doesn't protect us for things like long-term disability insurance or other types of insurance. It's really just for general healthcare insurance. So there are some protections in place. But I think as, more and more genetic information gets out there, it is going to become a bigger issue, and we are going to have to take a more, I think, formalized approach, and not just in the U.S., but I think worldwide, in order to protect people that are getting genetic testing from that genetic information being used against them.
If I understood correctly, so if I get a test done because maybe I had some concern, that does not get shared with my insurance company. Is there anything that prevents the insurance company from starting to demand these types of tests before perhaps allowing you to sign up for their insurance?
No, they can't do that for general health insurance. I mean, they may be able to ask you, if you're going to get, for their hereditary breast and ovarian cancer example that was earlier, you're seeking approval to get, bilateral mastectomy as a preventative measure for that hereditary breast and ovarian cancer. The health insurance can ask for, documentation that you have a genetic change that would predispose you for that specific condition before they approve or reimburse for that, that procedure. But as a point of entry into the insurance field, they can't ask for that information.
That's really interesting because I can imagine that information is incredibly valuable to the health insurers there, and the ability to design premiums to match the risk profiles. In many ways, they've always done that, but they've done it on rather crude and granular information like do you smoke and things like that.
Yeah. It's fascinating. I mean, one thing from a business perspective, right? Like we are, after all, in a business school here, and we think about the business implications. There's also always an interesting trade-off between the interest from the private industry, the private labs, the private companies that are looking to do these tests, and the hospitals or the organizations that we view. Some of them are private too, but some of them are more, serving the public. What is the trade-off there? Are there going to be more players that come and have an expertise in a certain test and take it away from the labs inside hospitals and inside schools?
Yeah, the genetic testing, like the business model, is a tough model because it's at least for academic medical centers and small public laboratories, because the technology is expensive, it's not well reimbursed. But we feel like it's really critical for good patient care. And so we're doing it almost as a loss leader kind of situation, hoping that the insurance companies will catch up and start paying for this really critical testing at some point in the future. Whereas, the private laboratories are in a somewhat different situation. They have investors to kind of prop up that business decision. And they also, they are sharing or selling data in some situations in de-identified ways to pharmaceutical companies or other companies that might be interested in the genetic data so they can develop new drugs or new treatments for specific genetic variants. And so that also helps, I think, kind of prop up the business model to some extent until really the insurance catches up.
Yeah.
We talk a lot in this podcast about learning curves. I'm just kind of curious on this point about the cost of doing these tests. Obviously, it's come down greatly over the last few decades. Is there a continual path forward where perhaps this becomes less of an issue in a decade or so?
In terms of cost?
To do the genetic testing, so it just becomes so cheap that this doesn't become an issue anymore.
I don't know how far it ultimately comes down, really. I mean, I think $1,000 that was the goal of the Human Genome Project, is to get it to a $1,000 genome. And that's pretty much where we are right now. Some labs are certainly doing it for $1,000. It might come down a little bit more, but I think, as we learn more about the genome, we're asking more and more questions, and we might need more and more data. And so I don't think it really comes down a whole lot more. I mean, certainly it will continue to decrease somewhat. And certainly as we do more and more tests and we can, leverage volumes and those kinds of things, that the price will come down somewhat. But it's always going to be a fairly expensive test. I mean, just to kind of put it in a little bit of perspective, genomic tests at UVA are, on the order of $1,000. Most other routine tests that are in the laboratory are, tens to maybe hundreds of dollars, but genomics is like an order of magnitude more expensive than just about any other test that we'll do in the healthcare system.
I have two more questions for you, Eli, as we wrap up here. One question is, Mike mentioned that he did the 23andMe. Is that
23andMe.
Yeah. But we've seen, there are so many ads on TV. I do sometimes feel like I'm in in Total Recall. Do you remember that movie with Arnold Schwarzenegger?
Good cultural reference.
So I sometimes feel like that with all these ads for all of these types of companies that are, suggesting that they can tell me everything about my ancestors. How do you feel about that? Is that a welcome kind of novelty out there, or is that something that you're concerned by?
Well, I'm a little concerned about it. I've also done 23andMe. I think it's interesting. It gives you some interesting, I think, conversation starters. But really, I think what people want with that is to be able to take a look. I mean, it's of interest, of course, but they want to be able to take a little bit of control, I think, over their health to some extent and make meaningful changes. I think public awareness of genomics is certainly increasing all the time as a result of those ads. But really, I do have some concerns about many of those businesses because they're promising things for genomics that maybe we can't really deliver on. So we have this promise of personalized medicine that we're going to be able to, customize your healthcare just for you. We're going to improve outcomes, and we're going to do all this through genomics. And then you have labs popping up and telling you, they can tell your biological age, for instance, from your genetics, and then tell you how long you're going to live, and do these kinds of things that don't really have a lot of real clinical utility or real value. And so it's kind of diluting, I think, the impact of personalized medicine from the public perspective a little bit. So I do have some concerns, and that really is a big concern, honestly, of some of the regulation discussions that are going on right now around personalized healthcare and personalized genomics is how do we make sure that these laboratories that are advertising are actually delivering, clinically useful tests back to the people that are ordering them.
We often in our conversations around disruption get to a point where we recognize that the wild, wild west of discovery, the exploration situation where a lot of individuals are, tapping into a certain technology and trying to push it further is good to some point for industries, but then at some point the regulatory authorities have to kind of come in to exert some judgment and to get some order in place and protect the people. So it's very interesting to see that this keeps on popping up in our conversation. My last question to you, Eli, just to maybe end on a high note, is from your experience, you've seen this evolve and grow. What is the thing that you're most excited about as it pertains to kind of personalized healthcare?
I think there's a lot to be excited about. I think, the cancer treatments and the things they're doing with some of these, molecularly targeted drugs have been really excellent. The outcomes have really improved significantly. And so as we continue to develop recognize and develop drugs for specific, cancer mutations, and outcomes are going to continue to improve. I think that's really exciting. The ability to give families that have children with rare disease answers as to what's going on with their kids through, expanded genome sequencing and those kinds of things. That's been really exciting to see and really impactful for families and patients in order to do that. So, those are kind of some things that are pretty exciting. I think one thing that's really starting to come down the pipe a lot more that is really interesting and kind of exciting is this whole idea of liquid biopsies, where we can use, just a blood sample to really get a lot of information about, a lung cancer or colorectal cancer without having to go in and actually take a biopsy of those cancers, and just use the DNA that's circulating in your blood that is released by the cancer to do the testing and to monitor disease, and maybe even eventually to diagnose and predict, the onset of cancer even earlier than we do now. So those are, some things that are coming down the pipe that I think are really exciting. But the field just continues to mature, and new applications of genomics are really coming out all the time. And so it's an exciting field to be in.
On that last one, I'm not sure if this is actually even genomics, but I just recently turned 50, and the ability to use ColorGuard over the standard colon cancer test was a great pleasure to me over the alternative. Is that genomics, Eli, or is that not?
I don't think so. I think that's more, it's personalized medicine in the way they're using biomarkers, but I don't think they're using DNA in this case.
Okay.
Yeah.
Eli, this has been really, I got goosebumps there when you described some of those potential benefits. I think that it's very promising, and areas that give a lot of heartache and a lot of pain for families in many different stages of lives. And if we as a society can ease that in some way, shape, or form by providing more information, even if it's just information, I think that is a really beacon of hope. So thank you for all that you do, and thank you for spending the time with us. So Mike, having discussed this now and for some time, where do you come down?
Well, I was going to, you just kind of gave your answer. So I'm going to make you answer first. Good disruption, bad disruption, or no disruption?
Yeah.
Just want to put a finer point on it?
I definitely feel like, in medicine, it is already heavily regulated, right? So this is a field where I believe all eyes are constantly monitoring issues that we're worried about: privacy issues, fairness issues, equity issues. We haven't solved the problems for sure, but there are a lot of regulatory bodies involved. There is a lot of quality assurance along the way. So it's a field that already has some safeguards that I'm encouraged that developments like this can actually improve our lives and improve the treatment that we get and improve how we, just the amount of information that we have, which I think is great because, I grew up, again, I'll give a cultural reference on did you see Inner Space? Do you remember that movie?
I do.
So I was thinking about, when I was preparing for today, I was thinking about Inner Space. We almost know more about going to the moon than we do about inside our own bodies. So it's amazing to see that we're making big strides to learn more about what goes on inside of us and be better at understanding how it all works.
So not surprisingly, I'm in alignment with you today. Good disruption in my viewpoint. I really appreciate what you were saying about the regulatory apparatus, because I think you're right. This is fraught in many ways, like we discussed. It is not without some challenges. The promise of improving health outcomes is obviously incredibly attractive, and the hope that we'll manage those issues, and I think we can. So I'm with you. Good disruption, and hopefully we'll continue to see the development of this field and the successes they've already had, but those continue in even greater and bigger ways.
Wonderful. Well, thank you so much. I learned a lot today, as always, from you and from our guests.
So thank you, of course, to Eli, our guest. Also, as always, thank you to Gary, our producer, Becky, our lead researcher, and Mark Wahlberg for continuing to be the inspiration for so much of the work we do on Good Disruption.
We should actually encourage him to have, some of those cultivated burgers in his burger chain.
We're going to combine all of our podcasts into one giant podcast by
with,
the end
with
of this.
Mark, yes,
by
exactly.
the end of this.
Thank you very much, everybody. See you next time.
Good Disruption is a podcast from the University of Virginia Darden School of Business.